Hello everyone and welcome to this webinar about FiberPlanIT. We will discuss the planning and design for FTTx networks with FiberPlanIT and also show quite a large amount of details and demonstration in this webinar. So let me introduce myself. I am Jeroen van Haverbeke, Business Development Engineer for FiberPlanIT, and I am presenting this webinar together with Jonas Verstuift, who is Partner Manager for FiberPlanIT. So I will be presenting the slides and Jonas will show the demo parts of the FiberPlanIT tools. This is a short overview of what we'll be discussing today. So we'll start with an introduction where I will explain some general concepts and how FiberPlanIT tackles the FTTH planning problem. We'll move on to strategic planning and present the FiberPlanIT simulator in that phase. We'll move on to the network design, so the more detailed design for fiber to the home networks, and there we will present the FiberPlanIT designer, and we'll finish this webinar with the Q&A at the end. So some details about this webinar. We will present about 45 minutes of content, and after that we can move on to questions that you can ask using the GoToWebinar Q&A window. So you can enter your questions there and hit them. We'll treat your questions at the end, and if there are any more questions than we can treat, we will definitely follow up on this with you personally. After the webinar, there will be a short survey, so please feel free to give us feedback on this webinar. And then as a conclusion to the webinar, we will send you a link with the recording at the in the next few days. So first of all, what is FiberPlanIT? FiberPlanIT is a tool that we have developed that will facilitate the FTTx planning, and we are convinced that we can make sure that the process becomes smart, fast and easy. Smart, which means that we will have advanced algorithms in the software that minimize the total cost of your network. So we will go into this more detail in the rest of the webinar, so I'll skip that for now. The software is also fast in that we see a very big difference with manual design efforts as they are usually performed, and we can make calculations for several thousand buildings in a few minutes. We'll also show this later on in the demo part. And the final part is that the FTTx planning is also easy, so we will simplify your strategic and detailed planning process and make sure that you can, by using FiberPlanIT, turn your planning into profit. So a little bit of background about FiberPlanIT. We've been developing and marketing the solution since 2008, and in the years between then and now, we have done over 85 projects worldwide. So you can see the distribution of our clients across the globe, and we have with these clients planned more than 41 million homes. So FiberPlanIT is a solution that has been proven in the market, and we have a lot of satisfied customers across the world. Then let me define some terminology, because it's not always easy to describe what we mean with planning and design. So we see this as various phases in the network planning. So usually we start with the strategic planning, where we'll make certain choices about which technology will we use, which areas will we roll out, and so on. Once the decision has been made that there will be an FTTH deployment, we'll go to the design phases. So we have 4 design phases shown here. We have first the initial design, usually followed by a field survey, where you'll go into the field and check how realizable this initial design is. Usually there is some fine-tuning to make sure that the design can actually be built, and this results into a detailed design. Usually this is then pushed to a network build. For this, you would need 2 build plans. So these are the plans that you will give to your contractor, who will actually construct the network. And at the end, you would also have an as-built plan, because it usually happens that the plans are not realized exactly, so there might be some changes during construction, and you would store this into a network inventory tool. So this is these are the main phases that we see in the network rollout. And in this slide, it's illustrated which of the various phases that FiberPlanIT will play a role in or will have functionality. So first of all, the strategic planning in the beginning, where you make decisions about where and how to roll out. And then after that, the initial design and the fine-tuned design are also realizable with FiberPlanIT. We'll show this in much more detail later on in the webinar. In respect to terminology, so I will be using quite a lot of terminology, and Jonas as well, with regards to for example, passive or active optical network and so on. We will for now expect you to understand these terms, but we can definitely help you to links of other webinars that will explain this a bit more in detail. So if you would have more questions, please send us a message and we'll make sure that we have this explanation for you ready. Then moving a bit more into detail to the phases where FiberPlanIT can play a role. So first, the strategic planning, where we will answer questions such as what does it cost, how will we roll out, where, and how can we estimate the return on investment. This is performed by a FiberPlanIT simulator, which will be the first part of the presentation and demo. And the initial design, fine-tune design, is performed by the FiberPlanIT designer, which will be the second part of the presentation and demonstration. So let's start with the FiberPlanIT simulator. Strategic planning is, well, of course, a difficult exercise. For example, assume you would be planning a region of about 10,000 or 40,000 or 1 million homes. You need to have a certain starting point, and also some typical questions that need answers. For example, what will be the cost that we would need to invest to make sure that we can provide the network? So some terminology here that's used sometimes is the homes passed, homes active, homes connected. The homes passed is usually the cost that's needed to go to the premises of the customers. So what you roll out in the streets to make sure that they can have fiber. The homes activated, which is the HA, is the actual connection cost, so the final trench, the connection in the service center, and so on. And the homes connected is then the cost of total homes passed plus number of activated users, plus the cost of activated users divided by number of activated users. So it's a bit of terminology. We will focus on the homes passed and homes activated, and the homes connected is a derived cost statistic, which we will be able to do later on. Another question that's also very interesting is which design rules will we use, which architecture, which deployment method, cable type, where should we put the splitters, and so on. For all of these questions, FiberPlanIT simulator will allow you to perform various calculations and compare cost impact and deployment impact for the various choices. And also FiberPlanIT simulator allows you to go into detail about where should I start the rollout or where should I not start the rollout. So the matter is always that you need to have accurate answers. So for example, if you would have a project at 1,000 euro per home, in the case of the 10,000 home project, you would have a total cost of 10 million euro. For the other projects, the cost is even higher. So it's quite obvious that if you would make mistakes in your design phase, it's quite costly. And on the other hand, if you can make 5% of savings, that's a lot of money on a budget like this. So that's the one side. The other side, it needs to be fast, because usually when you're studying a business case, you need to go quite fast, because it's very necessary that you can go to the market fast. So FiberPlanIT simulator can be used to perform the three operations that are now shown on the slide. Let's first start with modeling the cost of your FTTx rollout. And let me illustrate a little bit a study that we've done in the past. So what you see here is a graphical representation of more than 200 areas that we have designed with FiberPlanIT simulators. And for each of these, we have made a mark on the graph. On the horizontal axis, you see the population density. On the vertical axis, you see the cost per home. So in general, this would show for a certain population density, what is the cost of rolling out in an area with this characteristic. The trend line is more or less clear, so you have clearly a decrease in cost. But if you look at a certain point, then it's very clear that you can have large differences between, for example, the 600 buildings per square kilometer, you have very big variations in costs. So if you would just start from a rule of thumb and extract from there, it's quite obvious that you will have very large differences and score or have an estimate of the cost that's quite far from the actual cost of the rollout, what network will be rolled out. So what FiberPlanIT does is we use the GIS data, which is the actual information on the geographical locations of streets and houses. We combine this with rules, and FiberPlanIT will calculate, create a model of everything that's going on there. So it will simulate the actual trenching of the cables and ducts, go to all the houses, and make sure that you have a very accurate model of what a rollout would be like. So you can see on the right hand side what the typical results are of a FiberPlanIT calculation. You will get a map where all of the equipment, cables and ducts and so on will be located, and you also see a bill of material with an overview of all the costs that are being incurred by this model of the network. All of this will be discussed more in detail during the demonstrations later on. So we check in a second thing that we can decide by using the FiberPlanIT simulator in the strategic planning phase is the optimization of our design rules. So we have various choices that we can do. Will we use an aerial or underground deployment? Will we use a cascaded way or a distributed way of connecting demand points and distribution points? Do you want to have one fiber per home or two fiber per home? And a lot of different other questions. So FiberPlanIT simulator allows to do various calculations on the input data that you provide, and in this respect allow to compare the resulting costs and impact of various choices. So I'll now hand over to Jonas, who will perform the demonstration of the FiberPlanIT simulator.
Thank you, Jeroen. So, like Jeroen explained, a challenge that you might be facing during the planning phase of your FTTH project is wondering what type of network you will try to roll out. What type of technologies should you use? What is the cheapest method to roll out your network, and so on. There's no straightforward answer, and everything depends on the type of area you're targeting, the restrictions you may have, and the cost of all the equipment you're able to use to build your network. With FiberPlanIT, we help our customers to face these challenges and give them the tools to make informed decisions. So let me show you now how we would make a cost comparison, rule comparison with FiberPlanIT. I've prepared an area, a workspace in FiberPlanIT Simulator, where I would like to compare 3 different area rule sets and 4 different underground rule sets. For my aerial rule sets, the type of rules are very flexible to set up, and I can compare. I can set up. I can configure for every layer of the network, the drop, distribution, or feeder layer, what type of equipment I want to use, and if I want to use aerial deployment. One thing that I'm interested in this rule comparison is what if I would put my feeder layer, so my feeder cables, I would put them underground instead of overhead. So for the feeder layer of this particular rule set, I have ticked off this small box. So for this rule set, no feeder cables will go overhead, but will only go underground. So this will allow me to put some extra security in my network in case of a feeder break for aerial. Another comparison I would like to make is point-to-point versus PON for underground. So for this point-to-point rule set, I've configured the technology to be point-to-point for all my customers in the area. And for a different type of rules, PON rules, I have configured this to be a PON. So all my customers will be served as PON. And the splitter scheme I configured here is that on my distribution layer would have 132 splitters. And the way the splitter schemes are configured in FiberPlanIT, it's very flexible. So I've configured another splitter scheme for multi-dwelling units, where if the amount of buildings, the amount of homes inside a building is increased, so is above 3, then a different splitter scheme would be used. One last rule set I have configured is even more complex, where I have increased the number of different splitter schemes. Next to these type of rules, we can also configure all the unit costs, so the material and labor costs that will be used for the equipment in my network. And we support different currencies as well. So this is the type of rules that we have configured for this workspace. This is only one part of the input data that is required. The next thing that is required is actually the area I'm interested in. So I have loaded a small area of around 700 demand points. What I loaded are the demand point connections, so the buildings I would like to connect. Next to that, also the street center lines, so the street network of my area. And because we're doing an aerial calculation, I've also loaded in existing poles that I'm able to reuse. Other input data that can be loaded into the software is possible central office locations, if you know these already. Also existing pipes or conduits or ducts that can be reused for my cables, and existing access structures like manholes that can also be reused. So now I've configured, the rules are configured here, the area is loaded into the software, and now I would be ready to do a calculation and apply every single rule set to my area. This would require quite some time, like a few minutes or so, but because the time is limited for this webinar, I've done this beforehand. And you can see the results on this nice overview. So for every type of rule that I have configured, you can see what the total cost would be to apply this rule to my area. Next to the total cost of the network, you also get the cost per home passed and cost per home activated. In this overview, you can already have your first conclusions, and you would see that doing an underground network on this area would cost about 2 times as much as an aerial network. Next to this overview, you can also view a design, so the actual design of the network, and open this in a GIS tool, but this I will show later on in the demo. And also you can get a detailed bill of material of the network next to the design. The results that you see here, I've exported these quickly into an Excel, where you can do some more analysis of your results. So one thing I was interested in was to see if I have my feeder underground, what would be the cost of this network compared to a feeder that is completely aerial. So for my particular area, it would be a cost of an extra 20% compared to an all aerial network. So this gives you the actual result of what it would cost, and can help you to make the right conclusion to see if you go for this underground feeder or not. Another comparison that we can make is that if we look at this first area, you see that doing a point-to-point network compared to a PON network would result in a 4% increase. So it would be 4% more expensive to go for point-to-point. But if we look at a different area, so then it would cost 11% more. So this really shows the importance of doing a calculation on each and every single area that you're interested in, because the results may vary. That's why with FiberPlanet Simulator you get more accurate results than just doing an extrapolation.
Thank you, Jonas, for this brief overview of the features of the FiberPlanIT simulator. So it very clearly shows how you can optimize your design rules and make sure you have the correct answers and correct data to base your decisions on. You can even go one step further and try to optimize the business case in adding additional data in the FiberPlanIT simulator. So when you're looking at the rollout of FTTx, of course, that's quite expensive, and you may be able to reduce the costs by reducing the coverage. So let's look at an example of this. This is a map that shows an area that we've calculated, where the blue dots are the demand points, so the houses or buildings where you want to route the fiber to, and the red, yellow, and green dots show the costs of each sub area to deploy the fiber to the home here. So you see quite clearly that on the right hand side, the green and yellow dots represent areas that will be cheaper to roll out as compared to the red and orange dots on the left hand side. So this shows that if you would choose to roll out the cheapest areas first, you would have to go to the right hand side, the city center, or a bit more towards the city center. So this clearly indicates that FiberPlanIT can be used to create this kind of heat maps, analyze them, and base your decisions on what you can derive here. Let's look into another example where we will add a set of geomarketing. So suppose you have some information about which customers live where. You know, if it's an industrial area or a residential area, people with young children or more elderly couples. So actual information about the customers you'll be targeting. Then you can add this information as well and make even more basic decisions on what will happen with your FTTH rollout. So if you look at the same kind of figure that we just saw, you would assume that the epicenter of your FTTH rollout will have to be here because these are the more cheaper sub areas. But for example, if you have also information about revenues based on the geomarketing data that I was just talking about, you can maybe roll out to the areas on the bottom left. Suppose this would be an industrial area where you are sure that you will get more customers fast because you have companies that will generate market share over there. So we can add the information about FiberPlanIT, how much does it cost, with other information about the revenues, and make sure that you your first investment will be placed on the correct area to create revenues as fast as possible. So some conclusions about the usage of the FiberPlanIT simulator. So you can get an accurate cost of your FTTx project within minutes, and you will get an optimization of the design rules. We've seen in previous projects that we can save between 2 and 6% of costs on your complete investment of your fiber to the home project. So this can be quite substantial. FiberPlanIT simulator can also be used to identify the most interesting sub areas. So starting the rollout with the areas that will make sure to get you the highest revenues and the lowest cost at that point. And all of this will be combined to make sure that you can turn your planning into profit and roll out the FTTx network from the start with an optimized respect. So FiberPlanIT simulator is very useful even from the very early stages of planning your initial network. So let's move on to the second application of FiberPlanIT, which is the FiberPlanIT Designer. So the FiberPlanIT Designer is focused on the initial design and fine-tuned design, as I've shown at the beginning of the presentation. The objectives mainly are to decide on the topology of what will happen with your FTTH network. So where should you put the fiber concentration points, which homes to connect to which fiber concentration points, and how to route various fibers, cables, ducts, and so on throughout this area. So let me show you a small example of this. What we're looking at here is a typical GIS starting point for FiberPlanIT. So you have the black lines, which are the streets. You have the various squares or the houses, and each house has one dot, which is the point of presence. So you need to route fiber to that specific point. If you would start and manually designing at the bottom left-hand side, for example, here, then yeah, it's not very easy to see what should happen first, because decisions that you make all the way at the bottom can impact something up there. So it's not easy as a human to see what should happen. FiberPlanIT designer has advanced algorithms that will compare various choices, and on each decision level this choice is being made to choose the cheapest way of deploying the network. So here you see the grouping of the various demand points, various buildings into clusters. Each red dot is then the fiber concentration point. And this is all done automatically using the choices and optimizations of FiberPlanIT Simulator. So that's only the first part, grouping them into the clusters for distribution. And then after that comes the next part, which is routing cables through this, placing ducts, and also making sure that the trenching is minimized, so we have as little trenching as possible. So that's what FiberPlanIT does basically. Jonas will go into much more detail during the demonstration later on. So the challenges that we face in this initial design phase is the uniformity of design. Let's move a bit more in detail here. So if we look at a certain area, small area here, then 3 different designs could be proposed by 3 different manual designers. And even for this small an area, we have possibility to have quite large difference. So you see that the cheapest area can already be 5% cheaper than the most expensive one. So again, it's quite important that you make the right choices and use the FiberPlanIT designer to minimize your cost at each stage. A small example of the cost optimization. So we've done a proof of concept with a customer. We made a design for 2,500 homes, and the original design that they made themselves was 8% more expensive than the FiberPlanIT design. So if you're looking at a typical cost of this project, this would be a gain of 200,000 euro on a project of this small size. So if you use it for a much bigger project, the gains can be even more substantial. And another challenge with the initial planning of your fiber to the home network is the efficiency of design resources. So as I've mentioned, everything needs to go quite fast when you've made the decision to roll out an FTTx network. And our observations in the market are that manual design in a drawing or CAD program can generate about 1,000 homes per engineer per month, which is also error prone and inflexible. Changes are not that easy to incorporate. If you look at the GIS design, so already some level of automation is involved there, cable object creation and so on, then we are looking at 3,000 to 5,000 homes designed per engineer per month. But with FiberPlanIT helping the designer and proposing optimized designs, so as I've shown briefly, the automatic preparation of areas and clusters, then we can go up to 10 to 50,000 homes designed per engineer per month. Most of the time will be in the data preparation, and the design itself takes only minutes. And this again shows, allows the possibility to compare scenarios and see what would happen if we choose point-to-point over PON, for example. Again, a small example that we've had with a customer. So we observed, or we heard that the manual design took a certain engineer 2 months, and we were able to perform the design in 2 days. That's again quite a substantial saving, about 38 man days, and the cost involved as well. So I'll move again to Jonas. I'll give the word to Jonas, and he will explain how this happens in the FiberPlanIT simulator during the demonstration.
Thank you, Jeroen. So for a demo of the FiberPlanIT designer, and to show you how we do an initial design with the FiberPlanIT designer, I loaded some input data in QGIS, which is a GIS, open source GIS platform. And we can call all the FiberPlanIT features from a small toolbar that we integrated with this GIS platform. We also have other integrations with other GIS platforms and network inventory tools where you can use the FiberPlanIT functionality. For our demonstration, I chose an area where we have building information, so we know we have the building layouts of this area, and we also have home points for each building, so we have the address locations for all the home points in the building. This is very extensive data that we now have loaded. If you don't have this level of detail for your area, or you only have address point locations, then that is also sufficient to start a design. This is also now a fiber to the home design that we will do. If you have other fiber designs that you want to do, like fiber to the antenna or fiber to the cabinet, and you know the locations for these points, then these can also be loaded into the software to do design with FiberPlanIT. The area that I have loaded here is an area of around 2,000 homes. Next to the address point locations, I also loaded in street center lines for the complete area. Now, FiberPlanIT has some automated pre-processing steps that makes it a lot easier and smoother to do a design on this network. The first step that we can do is create possible trenches by the side of the street for every street in the network. This will take into account the width of the street if it is defined for your streets, or will take into account the default width if it's not defined. Now, the software has created a lot of trenches for the complete area. It doesn't mean that every single trench will get a cable inside the trench. So these are just all the possible trenches that can be used by the software, and we would like to use as much information as possible so that the algorithms of FiberPlanIT can optimize in the best possible way. Next to this input preparation for the streets, we also have other input preparation steps to merge the home points into the building polygon. So as you could see, we have all different address point locations for each and every single building. What we want to do is create a single entry point for every single building where the fiber will enter the building. So let me just switch off the home points that we loaded into the software. What you see now, the green points, the green dots, are my demand points that will get a fiber connection. And if there were multiple address points inside a building, then this is reflected in the amount of connections that is needed for each and every single demand point. The next pre-processing step that is very interesting is moving the demand points to the side of the building polygon. So the connection inside the building will come from the street, and what this step will do is it will relocate that demand point that was located in the middle of the building and move it to the side of the building, and this will reflect in the end in our total bill of material. It will reflect the total trenching that is needed and cable length for the drop part of our network. So that again makes it a lot more accurate. So the next step that we want to do is indeed create these building lead-ins. So every demand point will get a connection to the side of the street, and FiberPlanIT automatically creates these connections. So it will make a connection between the demand point, so the building entry point, and the side of the street. What we can do with all the points and lines that have been created by FiberPlanIT, these can all still be manipulated. So if you would know, for example, that this building here, that the entry point is located on this side of the building, and by simply dragging and dropping the points, you can change this entry point. So every change that is made here is taken into account by the software, and will be used for the calculation. Now, I have done this change for all the buildings in my area. So I've made it more that it represents more the real scenario. I've done this beforehand, and I will load in that area that I've done where I've done all the corrections. So we have this state manager in FiberPlanIT where you can go into different states and see what the result is and the impact is on your cost. The next step that we want to do for our processing is create the possible crossings. So we will tell the software every single location where a cable and a duct could cross the road. So again, like with the possible trenches, not every single crossing will be used by the software to place cables. So as you can see, there are a lot of crossings, and not every single crossing will be used. The last step in our input processing is to save all the changes that we have done. So it's possible that we have removed some crossings or changed some possible trenches where the street is wider. All of these things will be saved. So this concludes the processing of the area. So the area is now ready for a calculation. The other thing that we need to configure before we can start a calculation is the rules and material. So these rules and material are built up the same way as the rules that we saw before in the FiberPlanIT simulator. So these are very extensive and can be modified to the needs of the customer. The scenario that we will do in this demo is a simple point-to-point calculation for my area. So the only thing that is left now is to start the calculation. So the rules that I have defined will be applied to the area of around 2,000 homes. This will take 1 or 2 minutes. And in the meantime, let me switch to a different area that I have prepared. So in this area, we again see all different demand points and streets, but we also loaded in poles, so existing poles, to do an aerial network. Other pre-processing input preparation features that are included in FiberPlanIT are for these aerial networks. So FiberPlanIT will automatically connect poles with an aerial connection, and the user is free to modify these aerial connections to the real-life scenario. We'll also connect the building to the closest pole in the neighborhood, or use other rules for these pole-to-building connections. Again, based on the real-life scenario or a field survey, the designer can change the demand point that it's connected to a different pole. Other input data that we can use is existing infrastructure. So normally existing infrastructure will get a cheaper cost than doing new trenching. So this is configured in the rules, and the data can be loaded into the software. So I've done a calculation beforehand for on this particular network, so for this input data. The rules that I have configured are cascaded splitter rules. So as you can see, the drop points will get 4-way splitters, and then the distribution point will get 8-way splitters, and I have some other more advanced splitter rules with 32-way splitters as well. So as you can see, no underground trenching is used because the aerial connections are much more cheaper for this particular part of the network. And if we move up, you can see that the existing pipe that we specified beforehand, so this part of the network, is being reused both for distribution and for feeder cable, as it is less expensive. In the meantime, the calculation of my other network, so the underground point-to-point network is finished. What the software calculated right now is all the cables and ducts that are needed for realizing my network, and also all the fiber concentration points, drop point connections, and central office location. Let me just switch off the possible routes to make it more clear which trenches are used. So if we zoom in a bit, we can see that these are all distribution cables, and only here a crossing will be made. So in our input data, we noticed that there were a lot of crossings, a lot of possible trenches that were available for the software, but the software optimized the network, optimized the clusters and the cable routing, and will only use one crossing here. The level of detail that you can expect from FiberPlanIT output it's very detailed output. So let me just step through the network that's been calculated. Starting from the demand point that we had, we get a drop cable where we get the size of the cable that is placed, and then also which this cable is placed inside a duct, in this case a microduct bundle with capacity 2. At the side of the road we will get a drop point which is connected back to the fiber concentration point, so the distribution point that's located here. This is done for every single demand point and drop point. You will get a connection back to the fiber concentration point, and then from this fiber concentration point you get the necessary feeder cables and feeder ducts moving back to our point of presence, our central office. The central office in this case is placed in the optimal position for this network design, so for this area. In case you would know the central office location beforehand, then this can also be loaded into the software, and then everything will be rerouted from your loaded central office location. Next to this detailed geographical output, we also generate a bill of material. So let me open this for this network. In the bill of material, you get a cost breakdown for every level of the network and see what the part is in the complete network deployment cost. You get the total cost of your project and a split between deployment cost and activation cost, and also for each home passed and home activated, what the cost would be. We loaded in some adoption rates and expected revenue, and also this will be outputted into this bill of material. On the overview, you really get the bill of quantity, and you can see for each type of equipment what the volume will be needed to realize your network, and what the related total cost is. The unit costs here that you see are the ones that have been configured beforehand in the rules and material. That's everything I wanted to say related to bill of material. So back to Jeroen.
Thank you also for this. Thank you for this overview of the FiberPlanIT Designer. So we've seen that the challenge of uniformity, optimization, and efficiency are easily solved via FiberPlanIT Designer and using it during the design process. So let me indicate that the fine-tuned design is also taken care of by FiberPlanIT. So what we've seen now is shown on the screen. FiberPlanIT uses GIS data and the rules to provide you with the optimal choices. But of course, sometimes it's necessary to indicate certain certain other circumstances. For example, the fiber distribution point cannot be put at a certain location. At that point, FiberPlanIT can lock objects and redo a calculation. So this will allow you to fine-tune the design and make sure that it is actually realizable, and that all the aspects that are involved in the field visit or the field inspection will be incorporated in the final design. So to conclude with the FiberPlanIT designer overview, so we've shown that the initial design can be or will be uniform optimized and also quite efficient to realize this. And the fine-tuned design can be adjusted to field output and still remain its optimized nature, making sure that the costs are as low as possible. Allow me to indicate some numbers that we've observed in the various projects that we've done over the years. So we can, in the initial design, save 4 to 8% of the deployment cost. So that's the total cost of investment of the entire network. We're talking about quite substantial numbers here. In terms of efficiency, we've observed that FiberPlanIT will help you to design a network 3 to 20 times as fast as if you would do it manually or with other tools. And finally, the fine-tuned design will make sure that the maximum level of optimization is definitely kept while adjusting to the field input, the site visits, and so on. So again, FiberPlanIT Designer will allow you to turn the planning into profit and make sure that everything will well, the focus will be on realizing the best FTTx network at the lowest cost. So here are some quotes from customers that we've had around the world. For example, one from the Belgacom incumbent operator in Belgium, who said that we had a high level of professionalism in determining the parameters and we helped them to optimize their FTTx projects. Some final remarks before we go to the Q&A. So we at FiberPlanIT will provide the software to perform this kind of calculation, but we also can support our clients with consultancy services and also a combination of the two if that's most convenient for your projects. We will not only limit ourselves to fiber to the home, but also a number of other FTTx, for example, building, business, cabinet, curb, node, distribution point, antenna, all of these can be modeled and will be optimized by FiberPlanIT. And FiberPlanIT does focus on the planning and design process before actually rolling out. We have a number of partnerships that will help you to make sure the field survey, detailed design, and workforce management will be at a level of excellence as well. So if you would like more information about that, please ask us afterwards. So let's move on to the Q&A session. We've had some questions coming in on the Q&A panel of the GoToMeeting page. So let's start with a question about the what is the required level of technical knowledge to be able to use FiberPlanIT? Can someone without experience of GIS use the software? So let me answer that. We have observed that our users, even if they are quite new to GIS, can easily take up the FiberPlanIT skills. So we do expect them to have some basic computer skills as well as understanding of basic FTTx concept. But using our online video tutorials, it's actually only a matter of hours before new users can start using FiberPlanIT and make sure that things are optimal in the designs that they produce. The second question I'll pass on to Jonas. The question is, how does FiberPlanIT represent multi-dwelling units or condos, multi-story buildings? So how does it represent it and how will it be handled in the results?
So in the demo that I gave, we had the building polygons and home point locations, so the address points, and there were multiple address points in the building. We gathered these to one single demand point. So we have one, so a multi-dwelling unit is represented by one single access point to the building, and the number of fiber connections that is required is also consolidated into this point. That's actually the way that it's represented. In the network design, we will get in our output, we will get the necessary equipment based on the rules that have been configured for multi-dwelling units. We will get the necessary splitters or closures that are needed inside the multi-dwelling unit.
Okay, thank you for that answer. Another question that we've had in the panel is, do you have integration with GIS solutions? If so, what are these softwares? So as Jonas proved or showed in the demos, we have a working integration with QGIS, which is an open source software and is the the interaction of FiberPlanIT as a standalone, so we deliver it with QGIS. But apart from that, we also have a number of partnerships with other companies that provide GIS solutions or engineering tools. So one of them is GE Small World with their PNI, Physical Network Inventory. You have an integration where the FiberPlanIT functionality is seamlessly integrated in the Small World user interface, so you can actually run the FiberPlanIT calculations from Small World. Then we have also other partnerships. One is with Keypro, so that's a Finnish cloud-based network inventory and management tool that we are integrated with, and also with the German company TKI and the software net. So these are the main integrations. We also have some others, but we can discuss this later on in detail. So another question that I've had here that I'll also pass on to Jonas is, can you distinguish between different types of surface? For example, if you would cross a street that needs directional drilling, or if you have reconstruction costs that are quite high, such as expensive tiling or concrete surfaces.
Yes, that is possible. Let me take back control and show you in FiberPlanIT how this is done. So we can specify for each type of trenching or each type of street, we can specify a cost that would be needed to dig this type of network, so cost per meter. As you can see here, we can specify different subtypes and specify the material cost and the labor cost for street side trenching, and also to cross this type of network, this type of street. And this corresponds with the data that's available in the input data. So for each type of street that's available in the input data, you can specify the costs in the rules and material of FiberPlanIT.
Thank you, Jonas. Another question that we've had here in the Q&A is it possible, or does FiberPlanIT allow to generate splice sheet and splicing diagrams? So the short answer is FiberPlanIT doesn't do that, and the long answer is that our main focus is on the automated planning and design of an FTTx network. So FiberPlanIT will make sure that you have an initial design that will be as optimal as possible, and then the further steps, the to build plans, splice diagrams, documentation, labeling, and so on, we will refer to our partners, of which I've just mentioned a few, and they will take the output, so the various deliverables, various output of FiberPlanIT, load this into their environment and make sure that you can generate splicing sheets there. So we refer to our partners who will provide this information to you. Okay, then another question that I have here for Jonas, which is, how long does a typical calculation last?
So for the calculation that we've done in the demo, this was an area of around 2,000 homes. The calculation lasted, I think, about 1 or 2 minutes. If we go up to areas of 10,000 homes, it can take a bit more, but normally within 5 to 10 minutes, the calculation should be finished. Yeah.
Thank you, Jonas. I see that we have time for one more question, and then I'll conclude the webinar. So the final question for today is, how is FiberPlanIT installed at the customer site? Is it client-based or cloud-based, or what's the way of installing this? So basically, FiberPlanIT is installed at the PC of the user, which will allow him to make use of the computing powers of his own PC. We don't depend on internet connections and or cloud servers. We do everything locally, And our experience is that the computers that are standardly on the market today are sufficient. So in terms of system requirements, it doesn't require anything special. It's just the material that is standard in the market today. Okay, that concludes the webinar of today. So thank you for your attention, everybody. We will definitely make sure that the recording of this webinar will be sent later on. As soon as the webinar is finished, we will transfer you to a survey. So feel free to fill in feedback for us there so that you can make sure that the next webinar is even better than the one today. Thanks for your attention and goodbye.